All right, this is Utah Middle School Math Project 1.2D. This is the second video covering solving multiple step linear equations, focusing on the different solving outcomes. A quick recap of what we did in our last lesson. We had this model and we saw, wait a second, those two look identical, with only one difference being that the same amount of tiles here are in groups and the same amount of tiles here are not in groups. And when we continued to solve, we realized that they look identical because they are, leading us to infinite solutions. At some point in our solving process, we realized, well, yeah, duh, obviously 2x plus 6 equals 2x plus 6. Or maybe we don't realize it then and we see 6 equals 6. Well, obviously. Maybe we go even another step, 0 equals 0, obviously. So when we get to those obviously true statements, that's when we need to interpret that to mean infinite solutions. Some things that we noticed when we were solving these, and even the ones that we did ourselves, the ones that we created, we noticed that the variable zeroes out. It completely disappears from the equation. So that's one of the things that we're going to be seeing. So keep that in mind as we continue in our solving process, looking at some of these other solutions. I left you with this problem. I wanted you to get a head start. Those who completed it have already discussed it in class, and now we're going to discuss it here on the video. What do you notice about this model? What are some things that you observe about this model? Good. Appreciate the number of hands here. Let's start with, is that Jamie? Jamie, let's start with you. Yeah, they do have the same number of x tiles. So 2x tiles here and 2x tiles here. But unlike our last problem where they were identical on each side, now we have 8 unit tiles here and a different amount of unit tiles here, 4 unit tiles. Well, that might not be an issue, right? Maybe it's still going to be fine. But we do see the same x tiles, different numbers of unit tiles. Let's write the symbolic representation. Actually, you know what? Let's write that observation down. Same number of x tiles. Is there any other observations before I move on to the symbolic representation? Any other things that you noticed? Gracie. Yeah, both sides are simplified. Good. Last time we did have to take one step to simplify before we could really see anything, but now we can see both sides are simplified. Sam. Good. And if you don't recognize that now, hopefully we recognize that at some point in our solving steps. But I'm glad that you see that now. We hopefully are seeing 2x tiles equals 2x tiles, obviously. 8 unit tiles equals 4 unit tiles. That should raise some flags right there. How is that going to work out? Just for the sake of consistency, I know on your papers it printed off with an equal sign, right? Mine doesn't, so I'm going to show that those are equal. They are balanced. Let's write that symbolic representation. So we have 2x tiles plus 8 unit tiles, which is equal to and balanced with 2x tiles and 4 unit tiles. So what are the solving steps? Before, when I had you discuss, I had you focus on your observations here. Start trying to solve this. What's going to happen is I try and solve that and make some connections. What is happening when we solve and why is that happening? Look at the structure of the equation. Why is that happening? Pause the recording and have those discussions now. Ready, set, go. What solving steps should we be taking here? What's the first solving step? Danielle? Yeah, I like that because, like I said before, I really like to collect the x's to one side. So if I want to get rid of these x's here, we're going to subtract 2x, balance it, and subtract 2x from the other side. I'm purposefully zeroing this out because I'm trying to remove it from this side. So I know that that's going to be 0, but in the process, 2x minus 2x, what happens here? It zeroes out there too. That was not intentional. It was just kind of a consequence of my solving steps. What am I left with now? 8, which is equal to 4. And how do you feel about that statement? Yeah, lies, exactly. Again, I hope that this reminds you of our chocolate problem. It should remind you of the chocolate problem where I lied to you from the beginning. I said it was balanced and it was equal, and obviously it's not. 8 is not going to be equal to 4. I did hear some interesting conversation. Some students said, well, we're not done solving, so let's pick up where we left off. 8 equals 4. Could we subtract 4 from each side? Yeah? So I'm going to subtract 4 from each side. 4 minus 4, what does that leave me with? 0. 8 minus 4 leaves me with? So what do I have now? How do you feel about that? Also a lie. Exactly. This is also a lie. So it doesn't matter when you notice it. The point is you should be noticing at some point that this makes us feel very uncomfortable because we're lying. What do we do when we have a lie? Think back to the chocolate problem. How do we interpret that? What does that mean? Maverick? Yep. But we have the same thing happening here too. Our tubs of chocolate, or in this case our X tiles, they completely disappear. But how do we interpret that? We have to be careful about how we interpret it. Why don't you take out your chocolate problem again? Review that, because we already know how to interpret it. You guys have just forgotten, so go back and review that chocolate problem. We're going to pause while students review the chocolate problem. And when we have lies, like we saw in our chocolate problem, how do we interpret that? What does that really mean? Timothy? No solution. When we get to where it's an obvious lie, when you know that A is not possibly ever going to be equal to 4, that's a lie, you need to interpret that as no solution. Compare and contrast that to what we saw here. This was not a lie. This was an obvious truth. A truth that's so obvious sometimes we don't even recognize what's really even happened. 0 equals 0. That's an obvious truth. We have to interpret that as infinite solutions. This is an obvious lie, which we have to interpret as no solution. It's not necessarily that it's not solvable. It is solvable, it's just that the solution is that there is no solution. Just like this, it is solvable, it's just that the solution is that there are multiple possibilities. It's infinite solutions or all real numbers. Yes, Fitz? The saying, all I know is that I know nothing. That is great. We know that the solution is no solution. That's a great connection. I like that. Okay, so now, what happened when we solved this equation? What happened when we solved this equation? And what is it about the structure of that equation that led us to this point? Jaden? Why? What happened? How did we know that we couldn't continue to solve it? Yes, when we solved it, we got an untrue statement. That is one of those things, but there's something else. How did we get to that untrue statement? What happened in that process of getting to that untrue statement? Talk with your groups. Should have discussed it last time. One last chance. Discuss it. We're pausing the recording again. And we're back. What happened in that solving process that led to the lie? How were we able to recognize the lie? Daxton? Not just one side, right? In the process of trying to zero it out from here, what happened over here too? Yeah, it zeroes out from both sides. So, didn't we see that over here too? What happened when we solved this? The variable zeroed out. It completely disappeared from the equation. What's happening here? The variable zeroes out completely from both sides. It disappears completely from the equation. Let's write that down. I'm writing. Are you writing? Let's talk a little bit more about this. In both of these problems, the first one that was infinite solutions, we had the variable completely zeroing out on both sides. It disappeared completely from the equation. In this one, where it ends up being no solution, we have the variable completely zeroing out and disappearing from the equation. So how am I going to know if the equation, when it zeroes out and disappears, is infinite solutions or is no solutions? Another quick conversation at your groups, and then we're going to add that to both part C's from both problem 1 and 2. Talk with your tables. Pausing the recording. How do we know? What's the difference? How are we going to know if it's no solution or infinite solution? Tage? Yes. Not quite the question that I was asking, but you have a true statement. And that question is going to be helpful in another problem set in the future. So you're noticing that they are going to zero out because they have the same amount on each side, right? So we have 2x, 2x, so we know that it's going to zero out. Same thing here, 2x, 2x, same amount, so we know it's going to zero out. But the question is, they both had 2x, they both zeroed out. Why is it that this one was infinite solutions and this one was no solutions? What's the clue? What should I be looking for? Sam? Good. So if I have the same amount on both sides, what do I end up with here? It would be infinite solution. It's not that it's going to be 0. Look at, if I have the same amount on each side, I end up with 6 equals 6. How do you feel about that statement? Why do you feel great about it? Because it's obviously true, right? Is 6 always going to be equal to 6? We made it to an obviously true statement. So the variable zeroed out and completely disappeared from the equation, but we are left with an obviously true statement remains. And again, not just a true statement, not just something like x equals 3, but something that is obviously true, like 6 equals 6. That's when I interpret that to mean infinite solutions. Maverick? It didn't just have the x's equal on each side. It had the x's equal on each side, and the 6 unit tiles was exactly the same on each side. This one had x's on each side, and it had unit tiles that were different. So interpret that. What does that mean? When our x's disappear, what are we left with? We left with 8 equals 4. How do you feel about that statement? Yeah, you feel great? I'm so happy to hear that it fills your heart up with love, but why? Because for me, I feel a little bit angry about you saying that 8 equals 4. Thank you. Let's try that again. When we see 8 equals 4, how do you feel about a statement like that? Are you filled with confusion? Because you're like, wait a second, 8 doesn't equal 4. You guys are killing me. Let's refocus. Let's pull back the sarcasm a little bit, middle schoolers. I know. Now we can't even function without the sarcasm. Okay. How do you feel about 8 equals 4? This ties into Maverick's comment. How do we feel about 8 equals 4? Yes, the same x tiles were on each side, so we zero them out. They're gone. And you're left with 8 equals 4. How do you feel about that? Thank you. Yeah, you should be saying, no, I don't like this. You should not still be feeling great because we got rid of the sarcasm, right? You guys are killing my YouTube viewership right now. Okay. Seriously, let's refocus. Eyes on the screen. I'm not going to ask anymore. You feel uncomfortable with 8 equals 4. You are unhappy with that statement because you know that it is not true. So compare and contrast that to this one where we're like, yeah, 0 equals 0. I feel good about that. 6 equals 6. I feel good about that. We interpret that to mean infinite solutions because we feel good about this. This is an obviously true statement. Here we're uncomfortable We've got confusion. We've just got discomfort. We're like, wait a second, that's not true. This changes everything I ever knew before. So you know that this is a lie. So please understand what that actually means. In both cases, the variable zeroes out. It disappears completely. In our first situation, we're left with a true statement. In our second situation, we're left with an obviously false statement. When we see that obviously false statement, and that's all that we have left is something that we know for sure is a lie, that's when we interpret that to mean no solution. We're going to pause the recording as I have a serious conversation with my students. YouTube viewers can guess what's going to be happening. We'll come back in a second. All right, I paused the recording just to pass out candy to everybody. That's what really happened off the recording. But now all the YouTube viewers know that. Sorry, I couldn't help myself. Okay, summarize. What happened? How are we going to tell the difference between these two? Jaden. Yeah, exactly. That is a great summary. So we're seeing in both cases they have the same amount of x tiles. So if they have the same amount of x tiles, we know it's going to be one of our two unique solutions. If they have different unit tiles, then that's going to leave us with a lie. So that's going to be no solution. If they have the same number of unit tiles, that's going to be a truth. And so that's going to leave us with infinite solutions. That's a great summary. I also want you to make the connection that pretty soon we're not always going to be doing these with models, right? So when we're not doing these with models, we're not going to have x tiles to look at. So I want you guys to also be able to do that by looking just at the structure of that equation. That is a great summary. Maybe I will pause the recording and give everybody candy for that one. What I want you to do now is D. Build or draw your own equation. You can use unit tiles. You can just make it abstractly. Write an equation. I want you to write an equation that's going to produce the same result as above. We want it to end up with a lie. We want it to be no solution. Please create your own. And then with your group, solve that equation that you built. What do you notice? Pausing the recording as I do that. Ready, set, go. All right, Gabe, share with me what you built or drew. To what? Oh, got it. I like it. It's disguised. We don't see right out of the gate that this is going to be a no solution because it's not simplified first. So you have to take a step, kind of like we did on that first one. Let's simplify it. When I simplify this, I'm going to see two groups of x is going to leave me with 2x. Two groups of 4 is going to leave me with 8. So I have 2x plus 8 is equal to 2x plus 6. Can you see it already? We have the same number of x tiles, don't we? And I have 8 unit tiles here, 6 unit tiles here. Do you see the lie? Maybe not yet. Let's solve. Let's pretend like we don't notice it. Our solving steps, I like to group those x's to one side, right? So let's zero them out here. Balance it, do the same thing over here, and oh no, it zeroes out from each side, right? And what am I left with? 8, which is equal to 6. And we see lies, so we know it's going to have the same solution as above, where there is no solution. That's a great example. So solve the equation that you built. What do you notice? Well, what I noticed is we end up with another lies. The x's disappear, and we are left with lies. The variable disappears and only a lie remains. So let's practice this. We have a bunch of equations. Let's make sure we understand how we need to be stating our solutions. If there is one solution, we're going to state what that solution is. Don't let that confuse you. You have had lots of problems like this. In fact, every problem up until this point has been like this, where you solve it and you end up with something like, why are we talking? X equals 7. That is one solution. The solution is x is 7. But we also have these new options now as well, where it could be infinitely many solutions. We will write infinitely many solutions when we end up with an obvious truth. Variable disappears, but we have an obvious truth. We are going to write no solution when the variable disappears and we're left with an obvious lie. Now, not all of them are going to be obvious truths or lies, so not all of them will have infinitely many solutions, not all of them will be no solution. We're still going to have some that will have a single solution. So we're going to practice this. I don't think I want to do these on the video right now. I think I want to give students a chance to just practice this new skill, and then we'll go over some on the recording in a little bit. So pause the recording, work through some of them, and we'll see which ones we go over when we come back together. Pause the recording now. Okay, only continue on in the recording if you're ready to see the answers. I'm going to show the answers and then I'll go over them. Number 3 was no solution. Number 4, I got some of you on this. Number 4 is x equals 2. Number 5 is infinite. And number 6 is infinite solutions. Before I go over them, how did you do? Thumbs up or thumbs sideways or thumbs down? Okay. Good. Voices off. Let's go over them. Since most of you guys are showing me a thumbs up, I'm going to let you guys kind of be the guide. What's my first solving step here on number 3? What should I do? Thank you for the hand, Seth. Yeah, I want to collect them to one side. So I'm going to subtract the x here, balance it, subtract the x here, and notice what happens. Since I had the same number of x's, it zeroed out. And this is where you have to be careful. What am I left with? Yeah, what is the mistake that I made right here when I said 1 equals 1? What is that mistake? And how many of you guys have made mistakes like that in the past? Yeah. Charlie. Yeah. If we think of this as plus a negative, then it's not just 1 that we have left, it's -1. And -1 equals 1, I hope that you see that that is that's a lie. That's an obvious lie. So I don't write on my paper -1 equals 1 and put a box around that. I don't say lies is my answer and put a box around that. When I get to this point, you interpret that as no solution, and that's what you put your box around, saying I tried to solve it, and the answer is that there is no solution. This is the part that we put a box around. We have to make sure that that's on our paper. What are my solving steps here on number 4? And a lot of you guys did a weird solving step. It works. But I think that that's part of why some of you guys didn't quite catch it the first time around. Hayden. Yes, I also prefer to add 5x. If you add 5x, then you're not as likely to make the mistake that some students did make. If I add 5x, I'm choosing to keep the x's positive. So I have minus 5x, I'm going to get rid of the minus by adding, balance it, and we can see on the other side, 5x plus 5x, is that going to zero out? So it might have looked like we had the same number of x's, but these were positive x's, these were negative x's. They're not actually going to zero out. When it zeroes out from the right-hand side, 5x plus 5x is equal to 10x. Minus 10 is equal to 10. And from here, I'm going to add 10 to each side. That zeroes out. I have 10x is equal to 20. Divide each side by 10. And we end up with x equals 2. X equals 2 is a solution, so I put a box around that x equals 2. And just so that you can see where students may have made a mistake, because I want you to be careful with this, I'm going to redo the problem another way, the way that a lot of other students did decide to do it. They're like, hey, I'm going to zero out this 5x. So we subtract 5x. And then we subtract 5x from this side. And all students see is 5x minus 5x, they think that it zeroes out. What they're not paying attention to is the fact that it's negative 5x, taking away 5 more x, and that leaves us with negative 10 is equal to 10 minus 10x. You're still going to get the same answer if you continue on with that process. But I just want you to be careful when you're looking at zeroing these things out. Do they have the same number of x's? Please pay attention to whether those x's are positive or negative. 5. We've got to take a couple of simplifying steps here. The left-hand side is pretty easy to simplify. 4 groups of m is 4m. We're subtracting, so 4 groups of subtracting 3 is going to be subtracting 12. And yes, I could have changed that to adding a negative, but I'm also trying to save a little bit of time so that I don't always have to do that. This next one, it's really a good idea if you do change that, because it's not just 6 groups of m and 6 groups of 12, it's negative 6 groups of m and negative 6 groups of 2. So I have 10m plus a negative 6m. Negative 6 groups of 2 is plus a negative 12. So when I'm combining my like terms on this right-hand side, I have 10m plus a negative 6m simplifies to 4m. So I have 4m plus a negative 12, which is equal to, on the other side, 4m minus 12. Do you see the obviously true statement yet? If you see it, that's great. You can decide right now that it's infinite solutions. If you don't see the obviously true statement yet, then maybe take another step, where I'm going to subtract 4m to collect them to one side, balance it, and do the same thing to the other side. Zeroes out here, and ends up zeroing out here as well. So I have negative 12 is equal to negative 12. And if you didn't notice it before, I hope you notice it now. This is an obviously true statement. So when I get to that obviously true statement, I do not put a box around this. That's not the answer. When we get to this point, we interpret that to mean infinite solutions. And the infinite solutions is what I put my box around, because that is the answer. And number 6 was fairly easy. We have 4 groups of x, so that's 4x. We're subtracting 4 groups of 4. 4 groups of 4 is subtracting 16. And now I can see, if not before, you can see now that hopefully this is an obviously true statement. You don't have to take another step if you don't need to. If you notice that this is an obviously true statement, you can make that conclusion right now that this is infinite solutions. Okay, more practice. Just continue on. 7, 8, 9, 10, 11, and 12. I just encourage you to continue to practice. We'll go over a few more on this video before we finish up. All right, number 7. This is hurting my brain. This was no solution. Number 8 was also a no solution. That's all the time that I'm going to have, or that's all that I have time for, so I'm not going to show the answers to any of the others. We're going to practice that on another video. Let me quickly show you the answers here. I have 2 groups of x, that's 2x. And I'm subtracting 2 groups of 5, that's going to be 10. So I have 2x minus 5 is equal to 2x minus 10. Obvious truths for me are a little bit easier to recognize than an obvious lie. I usually don't recognize that right away. So I usually take one extra solving step where I would subtract 2x from each side, and now I see that it zeroes out. And I see that I'm left with negative 5 is equal to a negative 10. That's a lie. So I interpret that as no solution, and that's what I put my box around. The solution is that there is no solution. And I can see here I have the same number of x's on each side. And I can see that I have nothing over here, and I'm subtracting 4. So that leads me to believe this is probably a no solution. When I take that first solving step and I zero out the 3x on this side, it ends up zeroing out here. Look at what I have left. 3x take away 3x, I'm left with 0. 3x take away 3x, I'm left with 0, but I still have the minus 4. So this is lies again. When we get to lies, we interpret that as no solution. We're going to save the rest of these for video 3. We're going to finish up this lesson. So that's it for today. Thanks for watching.